welcome to this explainer. Okay, so today we're diving into a topic that is just incredibly fascinating, but honestly really sobering. When we picture a nuclear explosion, what's the first thing that pops into your head? Probably that terrifying flash, right? The massive shockwave and that iconic mushroom cloud towering into the sky. But what happens after that cloud fades? Because once the immediate visible destruction stops, a much longer, entirely silent story actually just begins. Today, we're going to unpack the incredibly complex, often completely invisible legacy that radioactive fallout leaves on our ecosystems. We're talking about how the science of a literal split second turns into a decades-long ecological cascade. Let's get right into it.
Over 2,000. 2,000. That is the staggering number of nuclear tests conducted globally since the very first one back in 1945. Think about that. More than 2,000 times, we have unleashed this immense, earth-shattering energy on our planet. And here's the crazy part. While the explosions themselves are literally the loudest, most violent events you could ever imagine, the environmental scars they leave behind, they're almost completely silent. But they persist for generations, deeply woven right into the fabric of the Earth, long after the history books have just moved on.
Because of this massive, enduring impact, the United Nations actually established August 29th as the International Day Against Nuclear Tests. This specific date marks a huge milestone, the closure of the Semipalatinsk test site in Kazakhstan back in 1991, after literally 4 decades of continuous testing. But, this day isn't just about looking backward. It's a critical reminder for us right now. It reminds us that to protect humanity, we absolutely have to protect our environment, because global peace and environmental health, they're tied together permanently. Section 1, where the fallout settles. Let's trace the radiation.
So, historically, there are 2 main ways these tests went down, and each leaves its own unique, devastating ecological fingerprint. First, you've got atmospheric tests. When a detonation happens above ground, it shoots radioactive dust incredibly high up into the atmosphere. And then global wind systems grab these particles and literally transport them thousands of kilometers away. We're talking massive fallout crossing borders, dropping onto distant forests, oceans, and farmlands, the whole shebang. Then you've got underground tests. These were designed to contain the radiation beneath the Earth, right? But instead, they created this slow-moving, totally invisible threat. These blasts cause massive ground fractures and radioactive gas leaks. They create severe groundwater contamination that can just slowly creep through aquifers, completely undetected for years.
And when we say radioactive fallout, what are we actually talking about? Well, we're talking about specific, highly persistent radionuclides, elements like cesium-137, strontium-90, iodine-131, and plutonium isotopes. These aren't just abstract science terms. These are physical materials that literally bind themselves to the soil. Once they're there, they disrupt soil microorganisms, totally mess up nutrient cycling, and can severely reduce how productive agricultural land is. And depending on their physical makeup, some of these materials stay trapped in that top layer of soil for decades, while others just slowly seep deeper, eventually polluting rivers, wetlands, and delicate coastal ecosystems.
Section 2, the threat to biodiversity. Let's look at the ecological impacts.
Here's a really sobering thought. Wildlife experiences a lot of the exact same radiation risks that we do. We're talking reduced reproductive success, horrifying genetic mutations, and severe developmental abnormalities. And it's not just the animals either. Plants suffer from stunted growth and produce way fewer seeds. But the absolutely crucial takeaway here is that ecosystems are interconnected networks. It's like a giant puzzle. You can't just damage one piece in isolation. Harming a single plant or animal species cascades through the entire community, throwing the whole habitat completely out of balance.
Section 3, moving up the food chain, or as scientists call it, bioaccumulation.
To really grasp how bad this gets, we need to understand a critical biological process known as bioaccumulation and biomagnification. This is the terrifying reality where radioactive substances enter the food web, and instead of getting watered down or diluting, they actually increase in concentration as they move upward through higher-level consumers. Let's walk through how this actually works in the wild. It all starts at the bottom. Tiny organisms at the base of the food web absorb radioactive particles straight out of the soil or water. Then, those contaminated organisms get eaten by insects, small fish, or birds. Finally, your top predators swoop in and consume them. And here's the kicker. Because radiation isn't easily expelled from the body, every single time a larger animal eats a smaller one, that radioactive dose multiplies. So by the time you reach the top of the food chain, the concentration of radiation is just massive. Section 4,
Human and indigenous impacts. This is where environmental justice comes into play.
This brings us to a profound, often overlooked issue of environmental justice. Historically, a lot of these test sites were chosen because they were considered, quote-unquote, remote or sparsely populated. But here's the thing, they were not empty. They were home to unique indigenous communities who suddenly, without any warning, found themselves exposed to this intense biomagnification through their traditional food and water. The health risks for these communities have been absolutely devastating. We're seeing increased risks of cancers, thyroid disease, and leukemia. And tragically, this hits developing children the hardest because their growing bodies are incredibly sensitive to ionizing radiation. These communities faced total cultural disruption, economic collapse, and forced displacement from lands they'd lived on for generations, often having zero say in the military decisions that changed their lives forever. You can see this massive global impact across several historical testing sites. Take Semipalatinance in Kazakhstan, where vast grazing lands were heavily contaminated. Or the tropical marine ecosystems of the Bikini Atoll in the Marshall Islands, where beautiful coral reefs were decimated and entire communities were displaced. Then you have the Nevada test site in the US, which still requires strict monitoring for groundwater contamination today. And way up in the harsh, freezing Arctic environment of Novaya Zemlya in Russia, the site of the largest nuclear explosion ever detonated, the ecosystem disruption was immense. What all this tells us is that from tropical islands to the freezing Arctic, no ecosystem is immune. Nature doesn't care about political borders.
Section 5. Can nature ever recover? Let's talk about the path to restoration. Trying to clean up and restore these former nuclear test sites is an immensely complex scientific headache. It involves massive soil remediation, hazardous waste management, and decades of long-term ecosystem surveillance. And the harsh reality? In many of these regions, returning the environment to its original pristine state is just not feasible. Certain radionuclides simply hang around for way too long. Because a total reset is often impossible, modern monitoring technology is our best defense. Today, there's this incredible global network using seismic sensors, hydroacoustic stations, and radionuclear labs that is constantly listening and watching the globe to detect any explosions and manage these long-term impacts.
Now, nature absolutely does possess some pretty remarkable resilience. In some of these former test areas, vegetation has regenerated and wildlife populations have actually bounced back after the testing stopped. But as we wrap up this explainer, I really want to leave you with a provocative thought to chew on. Yes, nature is returning to these sites, but are they truly healed? Or are they just silently adapting to a permanently altered radioactive reality? Because ecological recovery doesn't mean the risks have vanished. It just means life finds a way to endure. It's a stark reminder that our actions leave a permanent signature on this planet. It makes environmental protection and international cooperation literally more crucial now than ever before. Thank you so much for diving into the science with me today, and keep exploring.